Shalom and happy Hanukkah. Here's another example to help you with your optimization problem set. Here's sort of a different kind of problem. It's not so much as application E as the other ones, but it is something you should be able to do. And they're going to give you some kind of graph and a point, and you're supposed to find the point closest to the point given. Excuse me. You're supposed to find a point on the curve closest to one they give you. So this one's very visual. You really want to have a good picture of what this looks like to help you kind of figure that out. So let's get a good picture. So this is y squared minus 2x. I'm sorry, y squared equals 2x. And so this is sort of one of those parabolas opening to the right with some kind of little, stretchy, shrinky thing going on. It doesn't really matter. Just get a rough idea of what it looks like. If you think of this as y equals the square root of 2x, right? You know the square root of x looks like this. So square root of 2x is similar. And the negative square root. So that's basically what it looks like. The 0.14 is definitely up here somewhere, simply because if I plug in 1 here, I'm going to get the square root of 2. So this one, there's no chance it's going to be on here, right? We're trying to get the point on this curve closest to that point. So it's probably not here, it's probably not here, it's probably not here, it's probably not here. It's probably somewhere along this line here, right about there. Okay? Technically, it would be on, the perpendicular to the tangent is really where that intersection point should be. But we could do this using geometry, but we're going to try to do it using calculus instead. Okay, because sometimes these are going to get more complicated, but the concept is the same. So the shortest distance is going to be this. So this point is 1, 4. This point I do not know. I will just call it xy. And the shortest distance between those 2 points is literally going to be that straight segment, which means I can use the distance formula to find that distance. So the distance formula, of course, is the square root of, it doesn't matter which one comes first, but y2 minus y1. So y minus 4 squared plus x2 minus x1. Again, I didn't mean to actually write x2. X minus 1 squared, x, just x. Okay, the formula is x2 minus x1. So I could reverse these, obviously, because I'm just adding them, so it doesn't matter. But that's the formula. That's what we're trying to find the closest, so that we're going to minimize that. Again, we have an x and a y. That doesn't really help us, but luckily they did give us a way to compare them. So the easiest way probably would be to solve for x. So x is 1/2 y squared. I'm going to put that in over here. So the distance is going to be y minus 4 squared plus 1/2 y squared minus 1 squared, and there's my formula. I know these look the same. This is a y, and this is a 4. They both look like y's when I look on the screen. All right, so what do you do from here? Well, I know you're looking at this, you're like, I'm just going to put that in the calculator, but this one is doable by hand. It's not that bad if I can teach you just one little trick, and that'll make it a lot easier. This square root is going to, is really messing with you right now. You're like, oh my gosh, I'm going to have to do a power rule, chain rule with more power rules and chain rules as kickers. I don't want to do that. So here's a little trick. Instead of setting this equal to d, let's set it equal to d squared. Okay? If I set it equal to d squared, that'll take care of the square root. Remember, I'm basically squaring both sides. And of course, this just stays the way it is, just without the square root. And now let's take the derivative. Well, the derivative of this is going to be 2dd prime. I do need a chain rule kicker. Think of this as like your y squared, right? If this was y squared equals x minus 4 and 1/2 x squared minus 1, right? You'd basically have to do it implicit. So 2y prime, well, it's 2dd prime. This becomes 2 the thing to the 1. Chain rule is just 1. I don't have to worry about that. Plus 2 the thing to the 1 times the derivative of the thing, which is going to be 2 times 1/2 is 1 times y. There's my derivative. Let's clean that up a little bit. 2dd prime is going to be 2y minus 8 plus 2 times 1/2, of course, is 1. Y squared times y is y cubed. This is going to be negative 2 times y minus 2y. Clean that up. 2dd prime equals, the 2y's cancel, and I'm left with y cubed minus 8. Okay? Well, I want to solve for d prime, right? I want to know when d prime is 0 or undefined. D prime is going to be y cubed minus 8 over 2d. Well, I know what d is. D is just this again. Oops, it's up here. But I don't want to even deal with that, right? Because if that's going to be in the denominator, well, then my distance is undefined. That's not going to help me. excuse me, I'm sorry, that's not what I meant to say. My derivative is going to be undefined, right? So if I'm going to get a value here of 0, well then my distance is 0. Let me slow that down because I keep moving the sheet because the screen's too small. So let me start that again. I don't care about this being 0. That's not going to help. I don't want my distance to be 0, right? This is my distance. If this distance is 0, well then I haven't gone anywhere, right? Okay, so that's not going to be a valid value for me to use. So I don't actually care, even though that'll give me a critical value. It's kind of like those other scenarios where you get a critical value, but it's not usable because it doesn't make sense in the context of the problem. So again, if D is 0, this problem doesn't make any sense. So instead, I'm going to just focus on when the numerator is 0 to get my critical value. So when y cubed minus 8 equals 0, which would obviously mean y cubed is going to be 8, so y equals 2. If y equals 2, I can go right back up to here and solve for x, or right back here. If y is 2, well then x is 1/2 times 2 squared, which of course is 2. So it looks like my point on the curve is going to be 2, 2. There's the point. Okay, so 1, 4, 2, 2. The distance is going to be the smallest distance if you have any other point on the curve. And that one's not bad by hand as long as you remember this little trick. Okay? There is what we're looking for, and that's how you do it. Okay? So pick a point generically, make some kind of substitution, right? And then simplify as best you can. Worst case scenario, you get to here, and you can graph the end deriv and find the roots and go from there. But this one's doable by hand. Okay? Good luck with ones like that, and I will talk to you later.